Hey, welcome to our Alpha SDK webinar. My name's Rachel. Many of you will know me as a tech evangelist here at Lisk.
Hi, my name is Nazar and I've been working with Lisk over 2 years as a backend engineer.
Cool, and it's really awesome to be kicking off Friday morning, nice and early here in our office in Berlin with the kind of first webinar on our Alpha SDK.
Yeah.
So with that note, I'm just going to dive into the slides. So today we're going to be talking about the Alpha SDK. Those of you who've been in the community for a while will know this is a huge milestone. A lot of work had gone into this, and it's really exciting for us who are developers because it means that we can finally get our hands on some code and start building out proof of concepts and start playing around with our SDK. Give you a quick overview of the content of the webinar today. Going to be doing an intro. Those of you who have been following the project for a while, this may be familiar to you, but I think it's always useful just to kind of give you the overview of what the SDK does and what functionality it has. Then I'm going to be showing you how you can bootstrap your own local blockchain on a laptop, which is excellent for development. And then we're going to be creating a custom transaction, and the custom transaction is going to be a cashback transaction. And then finally, we're going to be interacting with the network, and we'll be rounding things off with a sort of short Q&A session that's all around the Alpha SDK.
Yeah, and one thing to highlight that please stick your questions around the topic that we have for today, and for any general questions, we still are available on our Discord channel.
Yeah. Start popping those questions into the comment box as we go, and we'll pick them up at the end. So, what can you do with the Alpha SDK? The Alpha SDK is going to allow you to bootstrap your own blockchain. That's a blockchain that's going to ship with a lot of the functionality that we have here with the Lisk main chain. So sending transfer transactions, registering delegates, voting for delegates, etc. All of the learning that we've gained over the last 3 years of building this main chain, you're going to be able to get that kind of out of the box with the SDK when you kind of build up your own blockchain. You can also configure attributes because you might not necessarily want to have the same block time or block rewards that we have by default. So that will be configurable. That's not something I'm going to show you today, but that's a pretty straightforward process to kind of tweak those. And those configurables over time as our SDK matures and as we iterate and grow, we're going to be adding to the configurable attributes. So at the moment it's block time, block reward, block size, and epoch time, and that's going to grow. And then finally, defining a custom transaction. I think this is really the most interesting part. And one of the questions that we often get is, can you write smart contracts using Lisk? And the actual answer is no. We have custom transactions, and we found for most use cases, this is actually by far enough to handle the bespoke business logic. You're going to have a glance of that today, and you're going to see what that means. And also it means that it's, for our development processes, it's much more slimmed down, and we don't have any the pitfalls that you might get with a smart contract. So it's an approach that works really well for us, and I'm hoping that you'll also like it as well today when we demo it. Okay, so this slide is just to give you an overview of the Lisk SDK ecosystem and how it plays with the Lisk main chain. As you know, the Lisk main chain has been operational since 2016, and if you've ever kind of transacted, sent Lisk, or if you've registered for a delegate, that's all happening on the main chain. And you can see that on the right of this slide. Here we've got 4 nodes. In reality, we know there's a lot more. I think there's close to 300, and there's 101 forging delegates. But you can see on the network, the kind of tech stack is made up of each of the nodes on the Lisk main chain. The tech stack is made up of Lisk framework, Lisk elements, and all of this is running on top of a Node.js runtime. If you go over to the left, you can see the tech stack for your DApp, and you can see it's actually very similar to the Lisk core. Again, it's using this framework, and the framework is pretty much the framework, the heart of the SDK. And then you can supplement that with Lisk elements, which is our modular library of JavaScript functionality, which is common throughout the Lisk ecosystem. And again, all of this is always sitting on a Node.js runtime. Which kind of brings me on to the next slide, which is really something that we've had at our heart since day one here at Lisk, and this idea of using technology that developers are familiar with and it's easy to kind of work with. that was our reason for choosing Node, JavaScript being, the ubiquitous language of the web and something that most developers have to learn at some point, and there's just a huge ecosystem around that. So it's a really good and accessible place to base our project. So with our installation, we have a dependency on Node 10.15.3, and the other dependency we have is Postgres. And again, Postgres, it's a database that you're familiar with, you're probably working with day in, day out if you are a web developer. And then optionally, we also have Redis as a caching layer. We're not going to use that today, but that you can use that to kind of improve your performance through caching. Today, I'm going to be talking you through this cashback example, and you can actually see there's a really good tutorial for this in our docs. You can go and visit that at the URL down here, lisk.io/documentation/tutorials cashback. So don't worry about making notes or trying to follow to the T. You can always rewatch this, and you can also go and check everything out in the tutorial as well. But before we dive into the actual code, I just want to give you an overview of what the business logic of a custom cashback transaction is. And this is a diagram to illustrate that. We've got Alice, and Alice is transferring 10 tokens to Bob. If that was just a regular transaction, of course, Alice would lose 10 from her balance and Bob would gain 10, and that would be it. But this cashback custom transaction, you get an inflationary bonus. In this example, we've chosen a 10% bonus. That's not coming from Bob's account. That's just coming from the network itself. Kind of similarly, we were thinking about a credit card cashback functionality or some sort of reward mechanism. So at the end of this, as well as paying Bob 10 tokens, Alice is also going to gain 1 token herself as well. Cool. So on that note, I'm actually going to dive over into my editor, and we'll start walking you through this. So just starting off here with just a clean directory, there's nothing in it, and we use npm, so I'm just going to initialize this. There we go, and once that's been initialized, we're going to install the SDK. We're using a specific version here. That's just because if you want to look at this in the future, you'll know which version of the SDK this works with, because as this is the alpha phase, we are going to be bringing changes in. So it's important to kind of just check that you're on the version, and change and improvements will come. So today we're using 2.1.0. Whilst that is installing, I'm just going to open up my code editor, which I think is here, and I'm going to create a index.js. What's that? There we go. Index.js file. Oops, sorry, my bad. Cool. Let's just check on the progress of that. So the SDK is still, the SDK has installed. So now that we have it, I'll go back over, and I'm going to just write the very minimal amount of code that we need to write our own local blockchain. I'm just going to put that in here. So from the SDK, you can see we're requiring an application, the Genesis block devnet, and that's just the Genesis block for a local development node. And we're also importing in the config devnet. So these are just the default kind of development settings for both the configuration and the Genesis block to help you kind of start building really quickly. And then once we have those 3 things from the SDK, we can just initialize a new application using the Genesis block and the config there. So that's the line that I've just added. Now that we have that, we can just call the run method on it. And I'm just going to add some very basic logging and error handling. There we go. And this should be the only bit of code that we need to actually run our blockchain locally. As you see, it's very minimal, and it's also very similar to Express.js, which is handy if you are a Node developer. So coming back over into my terminal, I'm just gonna Node. So we use Node to, we don't use npm scripts, we use Node. And actually a colleague here, Michael, he wrote a very thorough blog on the reason for that. So I recommend digging that out. We'll post a link to it afterwards. And we also use Bunyan just to give us some logs in a kind of a prettier and easier to read way. So now that that's, now that I have that, so.
And guys, feel free to ask any questions. I'm waiting for those.
Okay, so just throwing one small error with the database, creating a duplicate database object for the same connection, and then just check this out quickly.
You may be running an existing application already.
Just double check that's the right code. And then, cool. So there we can see we've kicked off our blockchain and it's initialized it, and it's gone through a lot of steps to set it up. And we're also enabling forging on these accounts. Of course, this example, we just have a single node running on my computer, but it's actually created all the forging accounts for the 101 delegates. So it's generated the public and private keys for those, and the accounts are set up. So you could take this and you could start building out a network using it. But as I say, today, this is just a demo, and we're just going to be using the single node locally. And here, after it's set up the forging accounts, we can actually see that the blocks are being processed, and every 10 seconds we're seeing a new block appear down here, which is pretty cool. Of course, Lisk is a default 10-second block time, and that is one of the configurables. So if you decided you wanted to have a block time of 100 or maybe 5, then you can go and configure that. Here we go. So now that we've got our own blockchain running locally, and we've bootstrapped that, the next thing that we're going to do is we're going to create our own custom cashback transaction. So I'm just going to create a new file. Here we go. And we'll call it cashback transaction because we're not super creative with the names here. So here we go. And we're going to be pulling off a couple of things from the SDK. As I mentioned when I was talking you through the business logic, this is a very similar business logic to a regular transfer transaction. It's similar to just sending, if I was going to send Nazar some Lisk, but we just have this extra bit of a business logic. Because it's similar, it means that we can actually just extend the transfer transaction. We don't need to write everything from scratch, which makes things nice and easier for us and allows us to kind of get going quickly. So because we're going to be extending the transfer transaction, I'm going to import it in from the Lisk SDK, and I'm also importing in a big number because we always want to make sure that we're handling large numbers securely, being JavaScript. So now I'm going to create my cashback transaction class. And as I mentioned, it's going to be an extension of the transfer transaction. We have to give it a type number, and 0 to 9 are reserved for the Lisk main chain, so we can give it a type of 11.
Yep.
And then we'll set a fee, and this fee is equivalent to 0.1 Lisk.
Just to highlight, because 1 Lisk is equal to 100 million Bedos, so 10 raised to power 7 is 0.1 Lisk.
Cool. Yeah, we're going to be seeing Bedos when we work with this, which is the smaller kind of more granular version of Lisk. So now that we have that, we need to write. So now that we have that, we need to write our apply asset. Apply asset is a really important method for any transaction, because this is where we're kind of adding our own business logic. So here we will add it. And the first thing we're going to do is just make sure that we use Super to connect it to the store, and also any errors that come through from that. The store is basically a wrapper for the database, so we need to connect this whenever we want to access account information or data. So the next thing we'll do is, once we've called Super on the store, is we actually use the store to get the sender's ID. So we can see that that's the line that I've just added. And now we're going to add some business logic. So here we have updated sender balance after bonus. And this is basically just using big number to calculate the cashback bonus, which in this case is 10%. So it will be a division of 10% of the amount that you send. Once you have that, we will then, again, we're going to use the store to update the sender's balance. Go. And then we will just return errors. There we go. Now that we have our apply asset, and apply asset, as you can see, it's really just added that business logic of adding the 10% bonus. It doesn't have all the logic around deducting from the sender's balance and adding to the receiver's balance. All of that is in the transfer transaction. So if you're curious, you can actually go and have a dig into that and have a look at how that file is structured. I imagine a lot of use cases of the Lisk SDK, you'll often be extending the transfer transaction and just adding your own bespoke logic on top of that. So definitely a file worth checking out. So now that we have apply asset, I'm just going to add another function, and it's called undo asset. And it's actually very similar to, it's actually very similar to apply asset. It's just the inverse of it. And we just add this because if the transaction doesn't make it into the blockchain in the end, we need to have a way to reverse it and undo it. And you'll see, looks very similar, but instead of adding on this extra inflationary bit, we're actually going to subtract it. So it's just the inverse of the apply asset. Next, and then finally at the end, we are going to just export this. Once we've exported it, we need to just save the file, and we'll just dip back over into our index.js file. And it's just a case of importing that in, and then registering the transaction on the application. And we do that after we've initialized it. So it's kind of a little bit similar to potentially like adding some middleware or something in Express. Again, trying to keep that developer experience more familiar for Node developers. So that should be all we need to actually start our blockchain again and start it with this new cashback transaction. So again, I'm going to go back over into my terminal, and hopefully, again, we're using Node and Bunyan just to run the blockchain. Cool, so now it looks like it started okay, and the blocks are coming through. And again, it's just the same. It's just a local blockchain running on my computer, but it does have the functionality to kind of build that out with the forging accounts that have been created. So now we have that. Now the in-string bit comes. We're going to start actually interacting with the blockchain, and we're going to send a cashback transaction.
Okay. Before go further, I would like to involve our audience here because I don't see any activity from them here. They are listening so quietly. I'm just posting a random question. In which year Lisk mainnet was live? So you guys can post these answers to the Lisk chat on the YouTube. So let's move further on the topic.
Cool. So like now we'll hit up and we'll send the transaction. Those of you who know, there's a number of mechanisms that you can use to send a transaction. You can obviously send transactions using Hub, and that's when you have a kind of really nice kind of GUI, and that's very good for like non-developers. We also have Commander, which is your command line interface. So that's quite useful for when you're working in the command line and you want to build things quickly. But today we're actually going to write a script, a very simple script that will do that for us. So I'm going to, sorry, here we go. I'm just going to make a new directory because this script is not really part of the main blockchain itself, the main code base for it. I'm going to make a script called, make a directory called a client, which the script will live in. So make the client, client, and then we're going to be calling our we'll call this file print sendable cashback. Basically what this file will do is whenever you send a transaction, you need a transaction object, and that's, you need a transaction to be signed, and you need to add some additional information. We'll see that in a minute. This file is basically just going to create that object, and then we'll use curl to send that to the blockchain. Actually, I'm just going to go back to the root directory here, and if I dip back over into my IDE, we see we've got a client file, and one more thing, we're going to be actually using an elements, a part of elements, the Lisk constants. So I'm just going to npm install that now. This one should be fairly quick to download, and then we can start writing the script. So first thing we're going to import in, obviously we need the cashback transaction to create the object for it. We're also going to require transactions, and this is, we need transactions for the utility, which will convert Lisk to Bedos. And we're also using epoch time. Epoch time is the time since the beginning of the blockchain, and this is a constant which is coming from the npm library the npm elements library that I've just installed. So we'll use that, and again, of course, we use a big number just to try and make sure that we're always handling numbers securely when they're large. So now I'm going to create the cashback transaction object, and here we have it here. So here you can see we're creating a new cashback, and we're setting the amount. In this example, we're going to take 10 Lisk and we're going to convert that to Bedos, because Bedos really is, I suppose, the measurement that the blockchain is running on. So we'll convert it down to Bedos, and then likewise for the fee, we're just going to keep it pretty constant with a fee of 0.1. So that's the fee that you're used to on the Lisk main chain. And then this is the address that we'll send it to. You could change that. That'll just be the recipient. And also adding a timestamp. We just have a very simple function here which creates a timestamp for you, because obviously the timestamp has to be unique for that. If it's static, and it won't send the same transaction twice. So this is basically just calculating the time. Once we have that, we are going to add this. Now, this is signing the transaction. Of course, you would never put your actual password even into the code. You certainly wouldn't put it into webinars. This is just an example. And then finally, we're just going to console log it and then exit the process. There you go. So just gonna, and we can just check that this is, first of all, before we try and send this, I'm just going to check that it actually is printing out as we expect. So I will go back over into the terminal, and I'm just going to do this. I'm actually just going to pipe it into a Python tool afterwards, because then the output will be a little easier for us and a little bit more prettified. Cool. So that's our transaction object. We can see the amount. This is 10 Lisk embedders. We can see the fee, and that's 0.1 Lisk embedders. The address, the ID, the address, the sender ID, and the signature. So now that we have that, we actually have everything up and ready to kind of send that transaction. But before we send the transaction itself, I think it's always good to just check the balances so that we can actually see the differences of what's happened. So
Rachel, before you just send the transaction, I would like to highlight that we do the transaction signature offline, so it's pretty secure that you do it offline, and then afterwards you send the payload to the network.
Yes, yeah. So this is being signed offline and then sent to the network. Cool. So first of all, let's check the sender's balance. And this is where we're going to start seeing some quite large numbers pop up on screen. So here we're just using a HTTP endpoint. And as you can see here, we're calling it to the accounts with the parameter of the address there. And again, we're just going to use the Python tool just to print it out a little bit prettier. So we can see here that the sender has a very large balance. This is in Beddoes, and in Lisk that would translate into 100 million Lisk. Not Lisk, 100 million tokens of this network, native tokens to my blockchain that's running on my machine. So there we go. And let's check the receiver's balance as well. So there we go. We can see the receiver at the moment, they're certainly not as rich as the sender. They have a balance of just 0 there. So now we have that all set up. We can use Node to print the transaction object, sign it, and then we'll use curl to send that to an endpoint on the node here. So I'll just show you what that looks like in terms of the bash command here. So we can see here, we're using Node, we're going to sign the transaction, print it out, pipe it in, and we're sending it to this endpoint on the node that's running locally on my computer. So let's do that. Cool. So that looks like it's responded with the amount that we send, which is, again, it's 10 Lisk embedders, the fee, and everything, and it says down here that's been accepted. So it looks like everything's good. Let's first check the receiver's balance to see that they received the correct amount. Cool. So the receivers received 10 tokens, and this is in the granular amount. Now, that would be true whether it was a cashback transaction or just a regular transaction. Mm-hmm. So actually to see, have we actually added our custom logic on top of the transfer transaction, we really need to check the sender's balance, because they should have a little bit more than they would have done if it had been a normal transfer transaction. So here we go. And so the balance is, and again, these are incredibly large numbers. So I think it would be best to just refer to a document. If we go back over here, so we can see, I'm not even going to try and say that because it's so many zeros there, but I think it's 99 million.
It's 999 millions and 999,000 and so on.
Well done. I'm glad you did that. But actually it's easier if we just look at it visually and we can work out what it should be. So if we come back over into here, so we can see this is the scenario, and it's just talking us through the amounts for us. We start off with the sender that had 100 million tokens, and we can see here that if it had been a regular transfer transaction, then we would expect them to have this many Beddoes. But we can see that because this is a cashback transaction, they've actually got a bonus here, and it should be this amount. So they've got this extra 10% bonus there. So if we just double check that and we compare this number to this number, we can say, actually, yep, that's worked, and that sent the custom transaction as expected. So I guess that wraps up the kind of coding walkthrough. Hopefully that's kind of given you an idea of how you can use our SDK to write your own business logic. Obviously, Cashback is quite a simple example, but you could have a transfer. You could have a custom transfer that sent extra messages or larger files or ratings whenever somebody paid.
Yep.
We've also we demoed recently our Lisk invoices, which when you create a transaction, you also add on some metadata. So the amount that you are requesting and the reason for it, etc., etc. So you can really start building this out. This is the most simple example we have, but I think it's the easiest way for people to kind of on board with. So that's why we've used it quite extensively. I don't know if you'd like to add anything more about the cashback transaction before we dive into the Q&A.
Yeah, we recently have a question that is there anything more than the cashback, and I would like to highlight that cashback transaction is just a use case for the learning purpose. There are a lot more possibilities when we have a custom transaction, and it's all open to whatever extent you want to have your custom logic in it. So it's not just the cashback.
Yeah, this is just a really simple example that we've chosen to make it kind of accessible for developers to start building on top of. We have a Hello World example, but in many senses is also functioning as a Hello World example. But something that I like to think of is if you wanted to create a decentralized social media site, then you could create transactions for creating a post or liking a post or adding a comment. So you can really start to build this out into much more sophisticated use cases.
Okay, so we got a question.
Yep.
From Skrillet, and he's asking, is it possible to register multiple transactions in the application?
Multiple transactions, multiple custom transactions.
Yeah, multiple custom transactions in the application. So we recently, in this example, we registered one custom transaction, which was cashback. So he's interested to know, can we register multiple custom transactions?
Yes, that's something we can do. And actually, if you are interested in that, that's something that we did with our list bills example. And you can actually see that if you go to our GitHub Lisk SDK examples, there's the code for cashback, there's a code for Hello World, and there's also another directory called invoice. I think we hadn't quite settled on the list bills name at that point, but check that out because we had a transaction for creating an invoice and paying an invoice. Again, this is still quite a simple example, but you can just keep adding as many transaction types and building out your business logic for your application.
Yeah, and I would like to add here that you can just register multiple transactions as well as you can register multiple implementation of the same transaction as well. So we have an extensive feature of we call matcher pattern in our SDK. So you can define your business logic to match a particular transaction implementation for a particular state of the blockchain. And I will be sharing more details on the Slack, on the chat for it. And meanwhile, I would like to know, Rachel, one more thing. So you have mentioned a particular address as a recipient ID. I would like to know from where this address is coming from, or is this a random address?
This address, I think this is actually one of the accounts that was set up to be forging on this network. So I think that's where it came from. So it wasn't completely random.
Okay. So we got another question which is really interesting. Is it possible to disable any of those transactions coming from the SDK which are integrated in the SDK?
So can we, so for example, could you get rid of vote for a delegate transaction or transfer transaction?
Yeah, that's the question.
Yeah. As a core developer, what would...
So it's not possible to disable those built-in transactions that come along the SDK because those are the transactions to drive the DPoS consensus protocol. So without those transactions, you cannot run the DPoS protocol. But this is a possibility that you can register you can register your own implementation of a vote transaction but you must have a board transaction in the system to run the DPoS consensus.
And presumably, if you started developing at a more modular level and then changing the consensus mechanism, then you would be able to do that. But obviously, it's a much larger job, non-trivial.
Yeah, it's much larger, but still possible within the boundary of our SDK.
Cool. Somebody says 10 cent and 10 cent 0.1 fee deducted, and then you also get 1 as a cashback. Yes, that is correct. That is, There's also a link. I think we shared the presentation in the, or if we didn't, we'll add it as a comment. So I will share the presentation so you have access to the file that has the kind of breakdown of the transactions and the amounts that are left. So
we got another interesting question that can we use this custom transaction with the mainnet token?
So right now, I think it comes back to potentially this slide that we had at the beginning, which is, there we go, this one. So this kind of shows you how mainnet and the chains that you build with the SDK are related right now. So currently mainnet is completely separate to the blockchains that you would build using the SDK. That was a decision that we made to kind of get the SDK out into the hands of developers so we can really improve the developer experience and start kind of growing with the community. With the production SDK, there will be interoperability. So there will be communication from Lisk core into the side chains. But with the Alpha SDK, we really want to just get it in hand so developers start building the proof of concept, start learning how to work the SDK, whilst we can work on delivering the beta and then production SDKs.
And we got, hope you answer the question. And then we have another interesting question called, can these sidechain tokens are compatible for the atomic swap within the Lisk ecosystem?
So atomic swap?
Atomic swap within the sidechain tokens. So if there are 2 sidechains running with the 2 different custom tokens, is it possible to atomic swap for both tokens or not?
From your perspective as a core developer?
From my perspective, it's not possible for now. And we are working, our science team is working and looking into it, but those atomic swaps will be available not within the side chains, rather with the main chain. But it's still the thought in progress, and our science team is still looking into it. So we have an interesting question further. Do we have a dedicated technical writer in our team?
This is a role we're actually hiring for at the moment. So we are as we've released kind of quite a lot of documentation, and documentation is definitely like an iterative and a process that we want to improve on. So we definitely appreciate any feedback, and we've had quite a few comments and feedbacks from the community already, and we really welcome those. We will be hiring a technical writer to kind of build that out as well.
Yeah, and just to add further to the question of Jackson, since our SDK is in the alpha phase and we are evolving and refactoring a lot of stuff on very high pace, so on some places you may find the documentation is not matching with the implementation, but it's just a matter of few let's say iterations that the documentation will be further improved.
But also we are very active on Discord, and we have a lot of developers popping in there as well. So if you are working with Lisk, definitely get involved, and we can actually answer questions just over chat, and we're available as well. So kind of join in the conversation there, and we also have a lot of knowledgeable community members there as well who are really amazing at helping out as well.
And one more thing, that our Lisk documentations is also an open source GitHub repository, so you can look there, and you can also open a pull request directly if you see if there is a problem or need some improvement there.
Yeah, so please add some issues, or if you have solutions and you want to create pull requests, we definitely welcome that as well.
So meanwhile, if we see, we got another question. I would like to know, discuss further with Rachel. How difficult do you found to use these large numbers while working on this example?
Oh, this is a question to me.
Yeah.
It's actually, I think it's actually fine. It just becomes, because we have tools in Elements to handle it, but I think it just gets a little bit more tricky when you actually have to come and say the numbers out loud, which is where they kind of get a bit more convoluted. But no, working with them is fine, and we have the tools in Elements to kind of do that conversion for you, so it's really not a problem.
Okay. And one other question I would like to know for the community knowledge. You specify a static value for the type, which was 11, I guess.
Yeah.
So is it possible that we change this value over the time of the blockchain? So once we started with 11, but later we change it to something else.
So from my understanding, if you change the type, that would that would create a fork in the blockchain. So that would be something that you can change, but it would require you to manage the kind of forking process of that. Obviously, if you're working like I am locally and you're just building a proof of concept, that's not an issue. But when you have your blockchain into the hands of like node operators, you'll have to require some coordination to make sure that everyone does kind of upgrade and a fork doesn't happen.
Yeah, I would like to add further that if once your transaction with that particular type is been part of the blockchain, then it's not possible for you to change it. But we have a pattern called a matcher pattern. In that you can disable the transaction for that type and then register a transaction with a different type for a particular height of the chain.
The other thing I would say also, I think we've added a link to this as well. Anyone who completes the Cashback tutorial, we would really like your experience of how you found it and how long it took you, and kind of points for improvement, but also kind of things that went well, things that didn't go well. So we've actually got a type form, which I think we'll share there as well, and we'd really value any input to that. That's something that really helps us get better as well.
So there's another interesting question. It's not related, but I would like to take there. How long it will take to change the voting system within the Lisk ecosystem?
So this is around the conversations we've had about improving the DPoS.
Yes.
So there is actually a lot of conversation on this, and I would say go to list.io/research.
Yeah.
We have a forum which our science team are very active on, and they've been speaking to the community a lot about this and also doing their own research in terms of making improving the system. So I think that's the best place to go. Of course, there's also conversations around DPoS and our consensus mechanism on Discord, and there's some channels specifically for delegate discussion, etc. But
yeah, for sure. And you can also jump into the Discord channel. So to want any particular or specific details of what we are looking or what our science team is searching for. And we have another interesting question from Mosty, which is, can we create a custom stores like we have store.account or store.transactions? And I would like to answer that question myself, that yeah, it is possible. Each of that store is actually linked with a storage entity. So if you want to create a new store, that probably may refer to a new storage entity you have to create, and then you link that storage entity with your store, and then you can store any custom data you want.
There's a question here also, actually. Where's it gone? Asking about the SDK and whether it's as powerful as smart contracts.
Yes.
I think that's actually a really interesting talking point. So actually you can, as I've mentioned, you can actually build out these custom transactions to a lot more sophisticated uses than we've just demoed here. This is just basically a kind of a learning tool, essentially. I think I'd be interested, how do you see the power of this versus smart contracts? Because I think arguably smart contracts can be a bit too powerful, and we've seen some issues with money getting locked up, the DAO hack, etc. So I'd be interested on your take on that.
From a technical perspective, I would never compare a custom transaction approach with the smart contract. They both have totally different approach to reach or target a solution for a problem. They both have pros and cons, and I guess the solution or the architecture must be decided based on the scope of your problem. Why we have reached towards the custom transaction and rather the smart contract is based on our years of experience and our vision for the blockchain industry as well. So we feel that custom transaction is more scalable solution, and it has more possibility to have your like more extensive integration with the even the enterprise environments as well, rather than the smart contracts. So this is just my thought on it.
So how are we doing for time? Have we got any more time for a couple more? I think we are running a little bit low.
Yeah. So I guess one more question I would like to add. In the printable cashback file that you created, you used a constant called Lisk. You used a package called Lisk constants to get the epoch time. Is this epoch time is somehow linked with the application epoch time? How these both values are linked together?
So the epoch time. So the epoch time is the time since the start of the blockchain. This is a configurable, right?
Yeah.
So this is something you could change in the configurable attributes when you start your blockchain. So when you import it in using elements, it is.
Yeah, if I would like to answer further here that this epoch time is directly linked to your application epoch time. So if you customize this value on your application, then you must that particular value while sending the transaction or creating a timestamp for the transaction. That will be nice. So I hope that's all we have. I don't see any further questions for now.
But yeah, please join us on Discord, and if you have a moment to kind of fill in our type form around the cashback, we really value feedback and look forward to kind of engaging with the community more and kind of webinars and technical content going forward. So it's been really awesome to sit down and do this today.
Yeah, and we will be posting a survey form at the description of the video, so you can also join there and give us your feedback.
Cool.
Thank you so much for your time.
Thank you.